This is the last section that is in chapter 9. In fact, it's the last section for the entire course. This is where you are dealing with graphing a parabola. So this is where you're told, we've been dealing with quadratic equations. So the graph of y equals ax squared plus bx plus c. So if you wish to graph this, what does it look like? So the graph of y equals ax squared plus bx plus c is either facing this way, it's like a happy face, or it's facing the other way, the sad face. Okay, so when it's facing upwards, you notice that's where it turns. When it's coming downwards, that's where it turns. Now this point where it's turning on this side is the lowest it ever goes. So this is also called the minimum curve. On the other one, it hits a highest peak and then it comes back down. So that's where we call him the maximum curve. So either way, or you can call it the happy face or the sad face. Okay, now what determines whether it's a minimum curve or a maximum curve? Okay, what determines it is the coefficient of the squared term. So if the coefficient of the squared term is greater than 0, it's a minimum curve. And if the coefficient of the curve, the squared term is less than 0, it's a maximum curve. But one characteristic about a parabola is that it's always symmetrical about this vertical line. It's like I can fold this curve into two and it falls on each other. Okay, so the name of the curve is what you call a parabola. And make sure you understand there's two shapes, okay, for it to look like y equals ax squared plus bx plus c. There's only two shapes. If you come up with a third one, you are wrong. Okay. So this point where it turns is what you call the vertex. Okay, the vertex is the turning point. So you notice that vertex is just a name. It's still made up of two numbers, x and y. Okay, so the vertex is just a name where you give that turning point in both cases. So there's 3 steps to this problem. The first thing you need to do is to find the vertex. So remember, vertex is just a special name that you give to the turning point, but you're still made up of an ordered pair. Okay, so there's 2 numbers that you need to look for. Now, the first number, that's right here, there is a formula. The formula is negative b over 2a. So x equals negative b over 2a is the formula to find the x coordinate of the vertex. As for the y coordinate, so you find y by substitution. Okay, so I'll show you how to do that. So before I go on, is there a way to help you remember this formula? Well, think about the quadratic formula, which I think most of you already memorized. If you recall, it was x equals negative b plus minus b squared minus 4ac all over 2a, right? So this formula that you see down here is really this piece and this piece. So it's really these 2 pieces that gives you that. Okay, so there you have it. So you really already memorized the formula. So really all you have to do is drop the discriminant, and there you have the formula for the vertex. Now the second thing you need to do, the next step, is to find the intercepts. Okay, and when we say intercepts, we're talking about 2 things. We're talking about x-intercept. At x-intercept, your y is 0. And then at y-intercept, your x is 0. So y-intercept look like 0 comma something, and x-intercept look like something comma 0. Okay, so that's the intercepts. And the last case is just to graph the parabola. And remember, your parabola only takes 2 shapes. It's either facing upwards, like a happy face, or facing downwards, like a sad face. Okay, there shouldn't be a third shape. Okay, so let's start as the first example. Can you graph the parabola? Say y equals negative 2x squared plus 4x plus 6. Label clearly the vertex and intercepts, if any. Okay, so let's start. So y equals negative 2x squared plus 4x plus 6. So make sure it's in descending order. And my a is negative 2, my b is 4, and my c is 6. So just by looking at a being negative 2, straight away I know it's a sad face. Okay, so once you have a negative, straight away you know your curve has to look like this eventually. Okay, so the turning point is what we call the vertex. So let's find the vertex. And vertex really is made out of two numbers. So the formula is x equals negative b over 2a. So it's going to be negative 4 over 2 times of negative 2, which is negative 4 over negative 4. So that tells you that x is 1. So x is 1 and tells you the first ordered pair is 1. You really need to look for the second one, the second ordered pair, which is the y. And that you find by substitution. So put back into the equation, y equal negative 2 times 1 squared plus 4 times 1 plus 6. So this is minus 2 plus 4 plus 6 makes it 8. So 1 comma 8 becomes the vertex. Okay, so vertex is just a special name for the turning point. Okay, let's continue. We need to look for the intercepts. So when you are looking for x-intercept, what you need to do is to set the y to 0. So when you set the y to 0, what you have is 2x squared plus 4x plus 6 equal to 0. This is a nonlinear equation, so I'm going to have to solve it by setting everything to one side. So in fact, let's just pull out the negative 2. So 0 equals negative 2, and I have x squared minus 2x minus 3. Notice I changed all their signs because I factored out the negative 2. Okay, so I didn't have to bring things around because I already have the 0. So 0 equals to negative 2. Let's factor that. I have x minus 3 and x plus 1. So can minus 2 be 0? Nope. X minus 3 equals 0 tells me x is 3. X plus 1 equals 0 tells me x is minus 1. So what this is telling me is that my x-intercepts are 3, 0, and minus 1, 0. So I have two choices there, okay? So there's two x-intercepts. Alright, let's go on to y-intercept. So at y-intercept, the x is 0. Okay, so now I'm going to put x as 0. So I will have negative 2 times 0 squared plus 4 times 0, which is really all zeros, plus 6. So that tells me y is 6. So what I have is the y-intercept is 0, 6. Okay, so I think we're ready to draw a picture. So draw your x-axis and your y-axis. Okay. And then you have the vertex at 1, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there, 1, 8. That's my vertex. I have a y-intercept at 0, 6. So there, 0, 6. I have x-intercepts at negative 1, 0, and 3, 0, like that. Okay, so I think we're ready. We have one dot here, which is the turning point. So here's the vertex. That's where I have to turn. So starting from the turning point, draw downwards. And starting from the turning point, draw downwards. And there you have the parabola. And true enough, we did expect it to be a sad face. So let's look at another example. Let's call example 2. So let's get you to sketch y equal, say, 2x squared, positive 3x, and a minus 5. So in this case, you notice a is 2, b is 3, and c is negative 5. So straight away, I know it's going to be happy face. Okay, so because my a is positive. Alright, but the place where I turn is called the vertex, so let's figure it out. And the formula is negative b over 2a. So it's going to be negative 3 over 2 times of 2, which comes out to be negative 3/4. Okay, so negative 3 over 4 is only my x-coordinate. I have to find my y, and I do that by substitution. So it's 2 times of negative 3/4 squared, plus 3 times of negative 3/4, minus 5. So this is going to be following the order of operations. Square this first, so it's going to be 9 over 16, minus 9 over 4, minus 5. So this is 9 over 8. This I might as well times 2 right now, so it's going to be 18 over 8. This is 5 over 1, so I'm going to times 8 top and bottom, so it's minus 40 over 8. So this comes out to be negative 49 over 8. Okay, so that's your vertex. Okay, the next thing I want to look for is my, say, y-intercept. And y-intercept is where x is 0. So that tells me y is negative 5. So that tells me 0 comma negative 5 is my y-intercept. Now I'm going to look for x-intercept. And that's where I put the y to 0. So 0 equals 2x squared plus 3x minus 5. That's a trinomial, which I think is factorable. Okay, let's try that. 2x and x, 5 and 1, positive and negative. Okay, so what you do is you put each piece to 0. And so you got negative 5 halves as one of them. And put x minus 1, 0 tells you x is 1. So there you have your two x-intercepts, negative 5 halves 0, and 1, 0. Okay, so every time it involves fractions, it's always good to convert it to mixed numbers so you have a feel of what those numbers represent. So 5 over 2 is 2.5. 49 over 8, what is that? 49 over 8, that's like negative 6 and 1/8. Okay, so it kind of gives you a better feel when it's a mixed number. Okay, I think we're ready to draw a picture. So this is y, and this is x. My y-intercept is at 0 comma negative 5. So 1, 2, 3, 4, 5. 0 comma negative 5. I have two x-intercepts, 1 at 1. So that's 1, 0. And then I have 1, 2, 2.5. So this is 3 and it's somewhere in between. So that's going to be negative 5 over 2 comma 0. And that's my 1 comma 0. So I have 1 dot here, 1 dot here. And I need my vertex. My vertex is at 3/4 negative and negative 6 over 8. So somewhere around here. So it's going to bring down somewhere around here. So it's going to be at negative 3/4 and negative 49 over 8. So this is where I need to turn. Okay, that's my vertex. So remember, you always start from your vertex going upwards in this case. Okay, so whether it's upwards or downwards, you always start with the vertex so you don't overshoot. And then from your vertex, you curve upwards as well. And try as best as you can to draw them symmetrical. Okay, so they should be the same on both sides. So that's one curve and that's another curve. Okay, so this is my happy face and that's my parabola. The parabola in this case is 2x squared plus 3x minus 5. So before you think that everything is going to look like this, let's try this one. Can you sketch y equal, let's try x squared minus 2x plus 4. Okay, so my A is 1, my B is -2, and my C is 4. Just because my A is 1, which is positive, tells me it's going to be happy phased. Okay, now my vertex, which is my turning point, that's my vertex. The formula is negative B over 2A, so it's going to be negative of -2 over 2 times of 1, which is really negative positive 2 over 2, which is 1. So that tells me the x coordinate is 1. And for me to get the y coordinate, I'm going to substitute 1 into every x I see. So that's 1 minus 2 plus 4, which is 3. So 1 comma 3 is my vertex. And then I'm going to look for my y-intercept. And at y-intercept, the x is 0. So when I put x as 0, my y is 4. So 0 comma 4 become my y-intercept. So 0 right here and 4 right there. Okay, now then I happily go and look for my x-intercept, and that's where I put y to 0. So 0 equals x squared minus 2x plus 4. So one setback is this is a trinomial that is not factorable. Okay, now back in chapter 5, if it's not factorable, you say it's not factorable and you're done. But not now, because now you have learned other methods to solve it. You can choose to do completing the square, or you can choose to use quadratic formula. So since it's been a while since we saw completing the square, so let me refresh your memory. Variables has to be brought to one side, and I'm bringing the constant to the other side. So it's going to be, actually let me just write my equal 0 this way so you can see better. Okay, so I'm bringing the 4 over the other side, and then these two fellows need a new partner, and the way to get that new partner is where you take the coefficient, take half of that. So looking at this number, I'm taking half of that and I'm squaring it. So negative 1, when you square it, makes it 1. So that's the new partner I need. And these three fellows come together to form a perfect square, which in this case is x minus 1 squared. The only thing is on the other side is a minus 3. So what you do next is you happily take the square root. The only thing is now it's going to tell you something, because you cannot square root a negative number. So this actually has no real solution. So this is where you start pausing and you start wondering what exactly happened. So you're trying to solve for an x-intercept, but yet there's no real solution. What this is really translating into is that there is no intercept. There is no x-intercept. Okay, so that is the translation. So how is that possible? Well, let's see. Let's draw the picture. That's y, that's x. I have a vertex at 1, 3, so 1, 2, 3, right there. 1, comma 3, that's my vertex. And I have a y-intercept at 0, 4. Okay, so I have to go through here and I have to go through here, but this is my turning point. So it seems to me that you have to turn here to go upwards, and you have to turn here to go upwards. So there you have your happy phase, but you notice this is a happy phase that's hanging up in midair, in which case it doesn't come down. Okay, so it's like going upwards. So in that sense, it never touches the x. So that's your curve. So it's not always that it has to touch the x-intercept. It is possible that you float above it, in which case that's how it looks like. Okay, but you still have your happy face or your sad face depending on the situation. Okay, so I need you to try some examples and look at the book's examples as well, and we'll do more when we meet in class. Okay.